welcome back to the deep dive. You know that feeling, right? Just drowning in this ocean of information, but really needing those key insights. Well, today we're kind of your shortcut. We're going to unpack this fascinating deep dive into Netx and their, audacious plan for what they're calling the small data network. Our mission really is to understand how Netx is proposing to build this whole new framework for exchanging data, one that really puts security, privacy, and efficiency first. It's a move beyond the big data idea we're all so used to, and we've got some great material here, architectural diagrams, snippets from the white papers to really get into it.
Yeah, and what's really transformative, I think, about Netx is they're not just tweaking the current systems, not at all. They're actually envisioning an entirely new internet of blockchains. And that's not just jargon, it's a fundamental rethink specifically built for this growing need for privacy-preserving data exchange, especially for those smaller but really high-value data sets, the kind that have huge potential but are often just too risky to share the old ways.
Right. So, okay, before we get into the technical weeds, let's zoom out. What exactly is this small data network Netx is building? And why focus on small data? It feels counterintuitive when everyone else is still chasing big data.
That's a great question. And yeah, it really flips the script on how we usually think about data value. So at its heart, the small data network is basically a decentralized ecosystem. It's engineered for secure, efficient, and fair exchange of, like you said, specific high-value data. Think of it less like a giant cargo ship for data and more like a secure, bespoke courier for your most sensitive information. Precision, really. Unlike big data, which is often about mass storage, aggregate analysis, Netx wants to unlock the value in distributed data that's currently stuck in silos, and crucially doing that without compromising security, privacy, or the owner's control, never losing control. And to make that happen, Netx brings together a few key things: this multi-layered blockchain architecture, advanced privacy tech, secure ways for systems to talk to each other, interoperability protocols, smart routing based on data attributes, and automated payments. Each part is pretty vital to the whole vision.
That distinction, bulk versus precision, that really clarifies it. Okay, so to actually build this precision network, Netx talks about an internet of blockchains. Sounds massive, maybe a bit intimidating. How does this multi-layered structure actually work? How does it support this specific secure exchange?
It's actually quite clever in its design. It provides both separation, compartmentalization, and seamless connection at the same time. The architecture uses three main types of chains: private, federated, and public. Together, they form this robust multi-level structure. It's all about balancing security, collaboration, and that global trust.
Okay, let's break those down a bit, starting with the private chains. Where do they sit in, say, a company's existing setup?
Right. Private chains are meant to be deployed right inside an enterprise data center. You can kind of think of them as these super secure, programmable gateways for an organization's data. Their main job is ensuring the integrity of the company's data and keeping tight control over who gets external access. If you look at that architectural diagram they provide, you see them securing what Netx calls private big data. And they also host private application services and even public application services, but securely, within the company walls. It's about keeping the sensitive stuff close, but still allowing controlled ways to interact with the outside.
Okay, so private chains lock down the data at the source, but what about when businesses need to actually work together? That's where federated chains come in, right? That seems powerful.
Absolutely. Yeah, federated chains are the backbone for collaborative networks. They offer flexibility through what they call verifiable openness and a layered structure. They're specifically designed to link up multiple enterprise data centers or even just different departments within one really big company. And this is where you find that middle layer they talk about with things called data process contracts. These are basically smart agreements on how data can be analyzed or transformed across different parties. And also data access contracts, which spell out exactly who can use what data and how. It's like the secure meeting ground for joint projects.
Which then leads us to the public chains. What role do they play in this whole interconnected system?
So the public chains are the global decentralized platform. They're the trust anchor for the whole Netx system, really. Their main job is to build this network of verifiable trust. They do that through peer-to-peer integrity verification. This is where you find the data network operators. These are decentralized groups keeping the network running, and the data routing contracts. Those are the smart agreements that govern how data flows. These public chains basically connect everyone, enterprise users, personal end users, to the wider network. They provide that universal, unchangeable ledger to verify everything happening across the whole system.
Okay, so we have these distinct layers, each doing its own thing, private, federated, public. But for it to really be an internet of blockchains, they have to communicate, right? How do these different types of chains actually talk to each other smoothly?
Yeah, that's where the cross-chain bridges come in. And you're right, they are absolutely critical. Can't stress that enough. These bridges act like the central hub, the switchboard maybe. They seamlessly connect all the different private and federated chains to each other. And really importantly, they connect them all to the public blockchain. Without those bridges, the whole thing would just be fragmented pieces. They're essential for letting data and value flow smoothly across the entire Netx network. That's what really makes it an internet of blockchain. And, when you think about linking potentially thousands of private corporate chains to one global public chain, well, the technical challenge there is huge. Making sure those bridges aren't just working, but are incredibly secure, fast, and resilient. That's a massive engineering problem Netx is focused on solving.
Okay, that multi-layered structure makes sense for organizing things and connecting them. But you mentioned privacy preserving right at the start as being core. How does Netx actually make sure sensitive data stays confidential, even when it's being processed or analyzed? Because that's a huge worry for anyone thinking about sharing data.
You've absolutely hit the critical point there. Processing data while keeping it secret, that's the core challenge. Netx doesn't just pick one method, they use a whole suite, really, of sophisticated privacy-preserving technologies that work together.
Like what, for example? Can you give us some, real-world ways this privacy works?
Sure. So first, there's Secure Multi-Party Computation, MPC for short. This lets, say, several different companies compute something together using their private data, but without ever actually revealing that private data to each other. Think about the competitive advantage there. Maybe several firms in a federated chain could collaborate on market analysis. They could identify trends together, find opportunities, all without any of their own sensitive sales figures leaving their systems. It's collaboration, but secure. A new kind of competitive intelligence.
Wow. Yeah, that is powerful for collaboration. Game-changing, really. What else is in their toolkit?
Then there's homomorphic encryption. This one's pretty amazing conceptually. Imagine you have a locked box with your secret financial info inside. Homomorphic encryption lets someone else, like an auditor, do calculations on the locked box itself. They never open it, never see inside. But when you get the box back and unlock it, the result of their calculation is there, perfectly accurate. It basically lets you compute directly on encrypted data. The decrypted result is exactly what you get if you'd use the original unencrypted data. So an application service could process data without ever needing to decrypt it first. Confidentiality stays intact the whole way through.
Hold on. The data stays encrypted while it's being worked on. That sounds revolutionary for privacy. But what about performance? Doesn't that kind of heavy encryption usually slow things down a lot?
Yeah.
How does Netx deal with that potential trade-off?
That's a very fair point, and historically, yes, HE has been computationally heavy. But Netx's design likely tackles this smartly. They probably use it selectively, where maximum privacy is absolutely needed. They can distribute the workload across their architecture, maybe use specialized hardware acceleration. Plus, there have been big advances in making HE schemes more efficient lately. So they apply these tools contextually, balancing privacy needs with practical performance. It's not about encrypting absolutely everything all the time. Then we also have federated learning. This is really relevant for training AI models. It lets you train models on data spread across different devices or locations using the local data right there. Only the model updates, the learnings get shared back centrally, not the raw data itself. So you could train AI on sensitive company data or even personal health data on someone's phone without that data ever leaving the secure company network or the person's device.
Okay. And one more term we hear a lot in the blockchain space, zero-knowledge proofs, ZK proofs. Where do they fit in Netx's privacy picture? What do they solve?
Right. Zero-knowledge proofs, or ZK, are another key piece. These let one party prove to another that something is true, but without revealing any information except for the fact that it is true. It's quite clever. In Netx, they might use ZK proofs to, say, protect exported data, or maybe verify that someone has the right access permissions without revealing exactly who they are or other sensitive details. It gives you that necessary verification, but with robust privacy. And all these techniques, MPC, HE, federated learning, ZK proofs, they're applied where needed across private, federated, and public chains. It really boosts security at every level.
All right, so we've got the secure foundations. We've got ways to process data privately. But data sitting protected in silos, even if it can be processed privately, isn't generating value yet. The next step has to be making sure these different data sources can actually talk to each other, right, in a standard, trusted way. How does Netx handle that challenge? True interoperability.
Exactly. The value really comes when data can connect and flow. And for Netx, interoperability isn't just about moving data bits from A to B. It's much more about setting up a standardized, secure framework. one that governs the whole interaction lifecycle for data. Everything from the initial negotiation, can I use your data, right through to the final payment or settlement. This is what allows that seamless data exchange. It does this by standardizing how several key things are negotiated.
Like what?
Specifically, what gets negotiated using these protocols beyond just the data itself? Well, first, the access terms. Who gets access? For what exact purpose? Under what specific conditions? Like maybe an enterprise user needs access to some private big data for a market analysis project. The protocols standardize how that request is made, verified, approved. It's like a digital contract negotiation. Then there are data quality levels. This lets data providers actually specify the quality, maybe how fresh it is, how complete, if it's verified, and lets consumers request data that meets certain quality standards. Precision again. And naturally, pricing. These protocols help negotiate the economic compensation, the payment terms, which then ties directly into the automated payment systems we should talk about.
So it's not just a tech handshake. It's like a full business agreement baked into the system, almost a smart contract covering the whole data usage deal.
That's a great way to put it, yes. And critically, these protocols are built to protect the interests of both sides, the data owners and the application's service providers or data consumers. They make sure everyone's preferences, their privacy settings, their security needs are respected all the way through the interaction. For instance, those data access contracts we mentioned on the federated chains, they're implemented directly using these interoperability protocols, operating via the cross-chain bridges. And they also link right into the privacy tech we just discussed, like maybe using ZK proofs during the negotiation to verify certain conditions without revealing sensitive underlying info. This could radically speed up processes that used to involve weeks of back and forth with lawyers.
Okay, so an agreement is reached, maybe some private processing happens. How does Netx then make sure the data, or access to it, actually gets where it needs to go, securely, efficiently? It sounds like it's not just sending a file, there's more intelligence guiding its journey.
You're right, it's not just a simple send. It's a pretty sophisticated mechanism they call efficient attribute-based routing. This system doesn't just route data based on an address. It directs data based on its inherent properties, its characteristics. It's almost like the data itself has tags that tell the network how to handle it and where it should go.
What kind of properties would guide this routing? What tags are we talking about?
Well, things like the data sensitivity level. Is it highly sensitive PII, like personally identifiable information, names, addresses, or maybe it's a company's trade secrets. Also, its processing needs. Does this data require secure multi-party computation? Does it need homomorphic encryption applied somewhere along the way? It also looks at things like jurisdiction and data sovereignty rules, making sure data stays where it's legally supposed to, complying with regulations like GDPR. And of course, it uses the specific terms that were agreed upon in the negotiation, the quality level needed, the purpose of the access.
Wow, okay, so the data itself sort of knows where it needs to go and the rules of the road for getting there. It's like giving your data its own personal security detail and a custom travel plan.
Ah, that's a fantastic analogy, yeah. And this smart routing brings some big benefits. First, enhanced security. It avoids sending data where it doesn't need to go, maybe routing it only through specific trusted nodes or applying extra encryption for certain hops. It also provides privacy reinforcement. It ties into that privacy-preserving processing, maybe directing data to specialized nodes that can perform MPC or HE before the final result is delivered. And it ensures policy compliance, making sure data only ends up where the access contract or the process contract says it's allowed to go. And those data network operators we talked about, the decentralized folks running the public chain, they're the ones actually executing this routing. They're guided by the data routing contract, which adds that layer of decentralized resilience. If one path is blocked, the contract can guide the data another way.
Okay, this is where it gets really interesting, especially for anyone thinking practically about using this. How does Netx handle the actual, transfer of data access?
Right.
And crucially, the payments, making sure everyone involved gets a fair deal automatically. This feels like where the rubber really meets the road.
Absolutely. This is the economic engine that makes the small data network actually function, that makes it worthwhile participating. Netx pulls this off through its core function, automated access and payment mechanisms, all powered by smart contracts.
So the access isn't just like handing over a key, it's conditional and then happens automatically.
Exactly that. Those data access contracts we keep mentioning, they act like digital gatekeepers. They only grant access when certain predefined conditions are met. That could be anything. Maybe payment needs to be confirmed in escrow first, or the identity of the requester needs to be verified cryptographically. This completely removes the need for manual approvals, which, as you know, can be a huge drag in traditional data sharing agreements. And for payments, it's usage-based and automated. Compensation is calculated and paid out based on actual data usage, not just a flat subscription fee. So for instance, an enterprise end user might pay per query they run against a specific data set. The system handles all the calculation, the tracking, the transfer, automatically, even for tiny microtransactions.
That's a massive change from how data is usually licensed, isn't it? It really shifts the power dynamic. Data owners aren't just passive providers anymore. They're actively monetizing, earning granularly based on real use. What are the benefits for the different sides involved, beyond just making things smoother?
Yeah, it's a big shift. For data owners, it guarantees they get fair payment for the value they provide. It takes away the risk of non-payment and really encourages them to share high-quality data. They know they'll be compensated fairly without needing, lawyers involved in every single transaction. And for the data consumers, the service providers, it massively simplifies settlement. The system automates all that complex billing, the usage tracking, the payment processing. It cuts down administrative headaches so they can focus on actually using the data to create value, generate insights. These mechanisms really are the economic engine, like I said. They flow directly from those interoperability protocols, they execute on the blockchain layers, and they embody that whole token-based incentive system.
Okay, a system this complex, this distributed, sounds incredible on paper. But can it actually handle real-world load? What does Netx say about its performance, its ability to scale up, to stay online reliably? Because let's face it, a network that's slow or crashes isn't useful, no matter how clever it is.
That's the million-dollar question for any distributed system, isn't it? And Netx seems to have designed for this explicitly. They talk about scalability and adaptability. The source material mentions it having a great capacity to adapt as users and data sources grow. And that multi-level architecture, private, federated, public, that's absolutely key to scalability. It distributes the workload brilliantly. Private chains handle the heavy internal stuff. Federated chains manage consortia traffic, and the public chain deals with global verification and routing. This setup prevents bottlenecks. No single point gets overwhelmed.
And speed, latency, that's critical if you're exchanging valuable data.
Totally. The system is designed, they say, to absorb increases in traffic while maintaining low latency. How? Well, probably through a combination of things. A lot of the heavy processing can happen off the main public chain, maybe within faster private chains. That efficient attribute-based routing helps find the quickest paths for data. And the fact that smart contracts automate so much cuts out the human delays, the administrative lag you see in traditional systems. It's a mix of smart design and automation.
And finally, just staying online. Availability. How do they ensure it's resilient? Doesn't just fall over.
Yeah, high availability is another design goal. The main pillar supporting this is simply its decentralized nature. There's no single central server that can fail and take the whole network down. For example, if one of those data network operators on the public chain goes offline, traffic can just be rerouted through others. Service continues. The distributed nature of both the public and the federated chains inherently makes it more resilient. So the takeaway is that Netx is built to be robust, ready to grow, and capable of supporting demanding real-world applications because of this distributed, multi-layered design. But, for an informed audience like ours, this decentralized resilience does raise interesting governance questions. How do they handle consensus? What if the data network operators disagree? The white paper suggests the data routing contract and the operators themselves enforce the rules, implying there's a robust protocol baked in for resolving conflicts, maybe preventing forks. That's something to watch.
Okay, so we've walked through the tech, the privacy, the data flow, the payments, the performance. Pretty comprehensive. But ultimately, for any network like this to actually take off, people and companies need to want to use it. It has to be usable, and there needs to be a reason to join. How does Netx plan to attract participants and keep them engaged, especially with tech that's pretty novel?
Yeah, that's the make or break question, really. User experience and incentives are absolutely crucial for adoption. Netx seems to tackle the user experience mainly by simplifying all that underlying complexity. The big challenge with blockchain tech is making it usable for people who aren't crypto experts, right? Netx seems to have two main approaches here. First, creating intuitive interfaces, basically hiding the complicated blockchain stuff so users, whether it's you as an individual or a large enterprise, can just focus on sharing or getting the data they need easily. Second, relying heavily on that automatic execution of smart contracts, because that eliminates so many manual steps: billing, negotiating access, getting approvals. It creates a much more fluid, efficient experience. Imagine, as an enterprise user, you request data, and the system just handles the access grant and the payment automatically in the background. No forms, no waiting weeks. That's a huge UX win.
That really does sound like a dream for businesses, cutting through all that red tape. But what about the motivation? Why would I or my company actually put our valuable small data into this network in the first place?
Right, that's where incentives become the driving force, the engine pulling people in. The main mechanism here is token-based incentive. They're designed to create this self-sustaining circular economy within the network. Basically, organizations, and maybe even individuals, get rewarded with tokens when they share high-quality data. This effectively turns their data, which might just be sitting there otherwise, into an active source of revenue. And these tokens aren't just like loyalty points, they're the actual medium of exchange used for those automated payments we discussed. It creates this sustainable economic loop. It's a powerful motivator because it offers a way to monetize data fairly granularly in a way that wasn't really possible before. And the ultimate goal behind all this is to enable everyone participating to add value and obtain useful services. To foster a really rich marketplace for data and empower developers to build new, innovative applications on top of this trusted, privacy-preserving network.
Wow. Okay, we have really gone deep today into Netx's vision for this small data network. From that multi-layered blockchain setup, the really clever privacy tools like homomorphic encryption, through the smart routing, the automated payments, those crucial incentives, it's clear this isn't just some vague concept. It feels like a thoroughly designed ecosystem aiming to tackle some really fundamental challenges in how we handle data today. What really sticks with me is how they're trying to redefine data control, making sure it doesn't really leave the owner's grasp, and that sophisticated mix of privacy tech ensuring confidentiality, even during processing. That feels different.
It absolutely does, and it really brings up an important question maybe for you listening right now. In a world that seems obsessed with just collecting more and more data, these vast oceans of big data, where does the real power lie? Is it just in the sheer volume, or is it perhaps in the precise, the secure, the incentivized exchange of valuable small data? It's worth considering how a network like Netx really challenges our basic assumptions about who owns data, what gives it value, and what that shift could mean for innovation, for privacy in the coming years.
Definitely food for thought. Until next time, keep digging, keep learning, and thank you for joining us on the Deep Dive.